Today we're going over horizontal transformation. The one in particular will be the horizontal translation, which occurs when you translate or shift a constant to the x value before squaring. Now if we look at our transformation form, which is also known as the vertex form, everything inside the parentheses will be classified as a transformation horizontally. This is because it is affected by the square. It changes the x value before it is squared. This is also the same for our function notation, where we still have our parentheses set, showing that our variable is affected before we square it. I'll find out where my mouse is. There we go. Now, the particular transformation that we are focusing on today will be our c variable, which if you look at the equation carefully, it shows a negative c. So whatever value that we do have for that is actually going to be showing the opposite of what's actually going on. That's what the negative means in this case. For example, our first one shows a graph of f of x equals x squared. We also have the table values shown for the parent function x squared. We have at a -3 for x. We have a y value of 9, and we continue the process with the basics to our parent function. To fill it out completely, draw the line because this is a continuous function. Now, the way we look at our next equation, our g of x equals x minus 4 all squared, is that we're taking our values and we are shifting them over, not to -4, but to a +4, because our equation shows that we are going to be having the opposite. This is why our vertex, which was originally 0, 0, is shifted over to location 4, 0. What this means, if we look at our equation, just focus on the expression, we have x minus 4 in parentheses that is squared. That squared is a way of showing that anything inside this parentheses is going to end up being greater than or equal to 0. So the way we find our new vertex to this is setting this up to equal 0. Now the value that would make this a true statement, we would solve for x, giving us x equals a +4. So that's where our solution shows the opposite, or why it shows the opposite. Now our table doesn't go all the way down, but one more value. If we look at our repeating factors of 9, 4, and 1, 9, 4, and 1, our next value would have been 0. Now the way this looks, if we have a positive value, is the same situation. All this information inside the parentheses is going to be greater than or equal to 0 because it is squared. If I wanted to find the new vertex, I wanted to set this y value to equal 0. I would have x plus 3 equals 0. Now to solve for x, I have to subtract 3 from both sides, giving me x equals a -3. And if we look at our -3 value, our new transformation is 0. So quickly to plot this out on this graph. First, we'll start with our parent function. Same values as always. I just hope I can draw a good enough parabola. Now, if I look at these values, at -3, we're starting at 0. There's our 1 input. At -2. At -1, we have our 4. At 0, we have our 9. And then our next values go off the graph. So we can see that our vertex is shifted over. We can use that knowledge to fill out the other half, since it does mirror. And our new vertex is also shifted over to an x value of -3. So, because our value on the inside of the parentheses has to be greater than or equal to 0, it helps us find our vertex very quickly by setting it all to equal 0 and then solving for our variable. As of right now, since there's nothing multiplying or dividing our x variable, we are just adding or subtracting a value. It's simple enough that we are just shifting to the left if it is positive, or right if it is negative, because our equation shows that we do the opposite of C. For the domain, this is a normal parabola, which will give us all real numbers. There's nothing limiting what x could be, but our range is limited. The lowest value that my y value could be is 0, and it can be any value greater than or equal to that 0, which is what we stated up here when it was squared. Since there's nothing added to it, it doesn't change what it can be greater than. And that's the same for our other example. Domain is still all real numbers, whereas our range is all y values greater than or equal to 0.